Thank you. My name is Misha Goffstein. I'm a founder and Chief Strategy Officer for AlertLogic in Houston. We do a lot of cloud security solutions, so a lot of what I do is spend time with cloud applications and help customers make sure that they're secure. How many people in the audience right now have applications deployed in cloud environments? So, good handful. All right. So here are the topics that we're going to cover today. We're going to talk about high-scale web application architecture. And the reason we're going to start with this is because while the talk is really about security, I think one of the main things you have to understand before you start advising DevOps teams and infrastructure teams on how to secure those environments is understand the world that they're dealing with, how they deploy their infrastructure, and a lot of the requirements they have. So we are going to take a look at sample application that we have AutoScaled and take a look at some of the architecture requirements for and implications on security infrastructure. We're going to touch on platform as a service, but this talk is primarily around infrastructure as a service. Most of the deployments that we see out there right now are still in the infrastructure world. Platform as a service has similar characteristics, but more complex. So if you have questions about that, we'll have time at the end of the session to answer some of those questions. So over the last 3 to 5 years, cloud application architecture has really evolved. What we're seeing more and more is where AutoScaling used to be the domain of startups that are scaling rapidly and need a lot of scalability. The more applications move in the cloud and the easier the tools become for auto-scaling applications, we're now seeing them come up in all sorts of use cases. So fairly traditional apps are now being retooled for auto-scaling, which presents a problem. The biggest problem that we see is that usually the infrastructure team, the development team, will not take security considerations into their architecture. So the applications will move to Amazon. They'll start to operate there, and security really becomes an afterthought. And there are reasons why this happens. A lot of times we don't help necessarily those teams get security infrastructure bootstrapped and automated the same way that they automate the rest of their infrastructure. So it's important to understand the principles that they're working with, and it's important to make sure that the security infrastructure you're deploying, it can also be auto-scaled and can also be deployed in cloud environments as easily as all other applications, right? So in large, this is a problem with culture. And when teams move to the cloud and they start using a lot of cloud infrastructure, their world changes and moves much faster. So even the language is different, right? Where they talk about role-based infrastructure, a lot of times us in the security world talk about role-based organization, but it goes deeper than that, right? The applications become a lot more ephemeral. They get deployed multiple times a day, and as you know, security infrastructure is not simple. It takes a lot of time and a lot of effort to deploy it. Usually you deal with kind of fixed deployment windows, and once the infrastructure is out there, it's difficult to change. So as a result, there's a bit of an impedance mismatch between security teams and cloud ops teams. And sooner or later, they stop talking. Sooner or later, their worlds go in very separate directions. And it hasn't stopped cloud infrastructure from proliferating. If you look at Amazon, and Amazon is still the largest cloud provider out there, there are a lot of production workloads out there. There's a lot of production applications. They're doing something like $4 to $5 billion in cloud revenue at this point. And that's just Amazon. That doesn't include anybody else. When we've talked to our Amazon contacts, for example, something like 70 or 80% of that is production, so it's actually serving customers. But when we deal with security engineers, usually they're left behind. So usually what happens is there'll be a line of business application owner. They'll move the application in the cloud. They're not going to consult with their security team. Security is at the very bottom of the list of their concerns, and it doesn't mean that they don't care. It just means that they don't want to slow down their deployments. It means that if they have plans to scale their infrastructure rapidly, and they think there is any possibility that the security team is going to slow them down, that causes them to move on and not ask the questions, right? So usually we see security teams come in much later, right? Usually applications will get deployed in cloud environments. Security teams will usually find out about it months, if not years later, and by then the train has left the station, and the perception is that security infrastructure is just too difficult to deploy in cloud environments, so you shouldn't bother trying. So developers essentially are on their own. They're hacking up their own ways to secure applications. They're not always right. They usually don't have the expertise in this area. So suffice it to say, this is a major problem. And so far, we haven't seen security be one of the core architecture considerations in most cloud deployments that we've observed. So we're going to spend some time on just the basic tooling that people use for AutoScaling, just plain infrastructure, right? We're not talking about security yet. And we're going to talk primarily about Amazon tools, mostly because Amazon is by far the most mature in this area. You're going to find analogs of these tools in other cloud environments. So, for example, Google App Engine has Orchestrator. Google Compute Engine is not as advanced with web tier AutoScaling yet, but Rackspace has actually caught up quite nicely, and Rackspace at this point has a fairly full-featured toolkit for AutoScaling infrastructure. But if you focus just on Amazon, there's a very rich toolkit that you can use to make sure that your security infrastructure scales in lockstep with all the applications that are being deployed by your application teams. So these are the most common tools. Really, AutoScaling, at least at the web tier in Amazon, revolves around Elastic Load Balancer. That's an Amazon load balancing service. I have a couple of words that I'm going to say about it later on. But essentially, most of the major AutoScaling components are built into ELB through functionality known as AutoScaling groups, right? Another key component is health monitoring. Amazon offers a number of ways to monitor your application infrastructure. You can use that. You can use those checks to trigger AutoScaling events, right? So based on whether or not either your security infrastructure or your applications are healthy or unhealthy, up or down, you can trigger AutoScaling events. Another key tool of choice is something to help bootstrapping and make sure that once you start deploying infrastructure in the cloud, it deploys rapidly. There's not a whole lot of wait time, and it can deploy within minutes. Usually 5 minutes is about what you're looking for when you scale infrastructure. So if the infrastructure you want to scale takes more than 5 minutes to configure and get to full operational state, chances are it needs a lot more automation, and it may need additional scripting to make sure that those instances can come up cleanly, right? So basic AutoScaling capabilities. I just mentioned Elastic Load Balancer, but at the very basic level, what you're trying to do with AutoScaling in Amazon is essentially manage healthy and unhealthy EC2 compute instances, right? So you want to make sure that if you have unhealthy hosts, you can pull them out. If you have hosts that are operating properly, but you need more capacity, you can scale and add more instances as the application starts to heat up, right? The scaling events themselves are triggered by Elastic Load Balancer, so you essentially develop most of your AutoScaling logic into the Elastic Load Balancing layer, right? And if you set this up right, you can actually get extreme scale out of these applications. I'll show you a couple of examples of what we've been able to do and kind of the level of scale we've been able to achieve. But assume that you're dealing with infrastructure that needs to be deployed in a fairly short amount of time. Again, less than 5 minutes. So if you have a security component of some sort that needs to be plugged into the application layer, and it takes more than 5 minutes for it to bootstrap, again, you got to reconsider things, and you got to really wonder, is the application team really going to accept this, and are they really going to deal with something that bootstraps that slowly, right? So if it takes a couple of days or a couple of weeks to set it up, that's a non-starter with most cloud deployments, right? Elastic Load Balancer. Elastic Load Balancer is a basic load balancing service. It's not the most advanced load balancer in the universe, but it does have a lot of functionality for managing scale out deployments. So you can add a lot more infrastructure just using ELB and AutoScaling groups as triggers. It essentially allows you to configure groups and rules by which you push AutoScaling routines, and I'll show you how those things are configured. The theoretical maximum of ELB is fairly high. I'm actually not aware of the higher end limit of it, but we've seen 20,000 transactions, 40,000 transactions flowing through ELB layer, and you can make sure that you scale this infrastructure across multiple availability zones, right? So you don't have to restrict this to just a single geographical domain. There are ways to auto-scale infrastructure in a lot of places distributed geographically, and that's another challenge for security teams. They have to make sure that their infrastructure, again, follows in lockstep, right? So here's how auto-scaling is configured in Amazon. There are 4 basic components, right? You're gonna configure your launch configuration. Essentially, a file that sets parameters for how instance is gonna start. We're gonna have a little bit of a deeper dive into it later on. You're going to configure auto-scaling groups. Auto-scaling groups are going to essentially define post-launch parameters, right? How are you going to instantiate these instances? Where are you going to put them? How should they be configured? The next step is auto-scaling policy. These are the rules by which your infrastructure is going to scale. And then there are things that happen during the scaling event itself, right? So once you actually start to scale, there are things you can do with your infrastructure as it starts to instantiate itself and starts to get deployed. So taking a closer look at the launch configuration, here are the things that get defined in there, right? AMI ID is the most basic, right? That's the machine image from which you're going to start from. You're going to define instance size. You're going to look at which block devices need to be attached to those instances. Key pairs, right? So identity as it needs to be attached to those instances, and security groups, right? So once you have that, at this point, the instance is spinning. It is now coming up. It needs to know which group it needs to belong to. So in the auto-scaling group configuration, what you're configuring are things like minimum and maximum number of EC2 instances that should be in that group, right? So one of the things you can easily do actually is say, this auto-scaling group should never have less than 4 instances, right? So if it has less than that, right, if instances die, or if they're unhealthy, for example, and some of the health checks come back on true, make sure there's at least 4 healthy instances in there at any given moment. You can obviously set maximums as well in case your application can't handle more web tier components and they overwhelm the database, right? So there are ways to configure both sides of those bounds. There are cooldown parameters you can set, right? Cooldown is actually especially important. There's always a cooldown period built into auto-scaling groups. By default, if you don't specify it, I believe it's something like 5 minutes. But that's essentially a time period when an instance comes up, traffic gets attached to it, it will spin for a while, it'll start accepting traffic. During that time, it's not a good idea to look at that instance with CloudWatch, meter it, and figure out the CPU is hot, right? Obviously, the CPU is going to be hot as the instance is coming up. So essentially, it's a warm-up period, right? So during that time, during the cooldown period, the auto-scaling routines are going to sleep for a while, let the infrastructure catch up, and you can set this as long as it needs to be, right? So if you need it to be 10 to 15 minutes, you can let your instances come online, start accepting traffic. At some point, things start to settle down, and that's a good time to go check to see if you need to spin up additional instances, right? The last thing that gets defined in auto-scaling groups, and this is, again, optional parameters, which availability zone you're gonna spin into, which VPC groups to use if you're using VPC, and most people are these days, and so on, right? Moving on, auto-scaling policy essentially defines scaling activity, right? So these are rules by which you auto-scale your environment. These are applied to auto-scaling groups, right? So again, CloudWatch metrics are probably the most useful tool for auto-scaling policies. That's where you define triggers, and there are different triggers based on what type of infrastructure you choose to scale on, right? So for some things, you may need to auto-scale just by knowing that there's a certain number of connections going to a cloud instance, right? So if you have a web server and you have more than, let's say, 5,000 connections going to it, you may want to say at this point we need to scale up, we need to add additional capacity. You can also do that through any combination of CPU, memory, disk, and other metrics. You can also do that for RDS, that's a database service for Amazon. So auto-scaling functionality and ability to scale triggers, for example, is fairly rich. There's a lot of flexibility you have in terms of how you're going to scale your infrastructure. And in fact, you should think about it in terms of groups of specialized infrastructure, right? So for example, when we deploy our applications, our web tier infrastructure, those are the servers that we have, they scale using one set of policies, but our web application firewalls, scale a different set of policies because they have different parameters, right? And usually WAFs take longer to warm up, so as a result, we have very different parameters for those WAF groups than we do for other tiers in our infrastructure, right? Last thing is the scaling event. Again, this is the act of scaling up or down. These are the things you want to do after you've actually started scaling, because based on that scaling activity, you may want to launch other things, right? So using the simple queuing service, you can send yourself a notification and let yourself know there are new instances now spinning up. If you have, for example, web application security testing as one of your policies, and what you want to do is say, every time there's an instance, even though it's coming up from the same set of AMIs, and I know the code that's being deployed in there, but I still have to run a series of automated scans, and I have to do a certain number of things for security. And when these instances come up, you can actually do that through the SQS service, send a notification, pull that out, and then launch whatever scans you may need to run, right? So as the infrastructure auto-scales, you can actually trigger additional actions and use this infrastructure to start to trigger other events, right? So scaling events are useful and very important as well, right? So here's an example. We're not going to go through every configuration screen. I think that would be a waste of time in this session, but there's a couple of ways of configuring auto-scaling in Amazon. The easiest one, there's actually a couple of wizards that are very simple. You walk through the wizards for each auto-scaling group. Pretty much everything you want to configure is configurable through the UI, but you can also do so at the command line. And there's a reason why you may want to do it at the command line. Imagine a scenario where security team and infrastructure teams are very separate teams, and they really don't work on the same projects, right? It doesn't mean that they should have to be in the same room necessarily when they set up their infrastructure. You may just want to inherit a set of auto-scaling routines from your security groups that says, every time you deploy a new application stack, also deploy this security stack in lockstep with it. And command line tools are very useful for that, right? So using command line tools, you can do exactly the same thing you can do with the UI. You can obviously do that with Amazon APIs as well. So this is, for example, a command that creates the auto-scaling group. There's a number of things you can do in here. Define the launch config, which you have created previously. The group name, minimum and maximum instances, configure the default cooldown period, assign it to specific availability zones. And there's even more flexibility with these command line parameters that I'll show you later. Using CloudFormation, you can actually define defaults, but then ask for user input for them to input in there. So if for example, there's some parameters that are going to be dynamic, right? And they're going to be dependent on, obviously the stack in Japan is going to look very different than the stack in EC2 on the East Coast, for example, right? Those parameters can be passed down through CloudFormation, and there is a way to kind of configure these auto-scaling groups to make sure that those parameters can be user inputted, right? Another example of configuration, you can configure auto-scaling policies. I mentioned earlier, for example, that you can use CloudFormation templates to set defaults and let users override them, right? So that's where, one of the things I don't recommend is nailing down auto-scaling rules 100%, where the teams that are actually going to start consuming this security infrastructure are forced into using your defaults, right? So if everything is baked into a set of scripts and it's not easy to change them, chances are at some point they're going to decide, this one doesn't work for me, I'm just not going to use it today, right? So it's a good idea to anticipate what they may want to configure. So we've done that for our customers, for example, and we let them choose their scale-up parameters, right? So normally it takes us about 60 seconds before we decide this WAF instance needs to auto-scale. Obviously, the customers can configure that if they need to, and if they know that their application needs to scale up much faster, then they're just more aggressive with it, right? They set it to a lower number, and those WAF instances auto-scale much faster than that. So if you go through this whole process, right, at this point you have a fairly dynamic environment that auto-scales up or down based on demand. The problem is that security is still not in play, right? We've done a whole lot of things, but at this point, it's just a pile of web servers and databases, and at this point, this application is essentially unprotected, right? So most of the cloud architects that we talk to understand auto-scaling really well. Ask them how do you deploy a WAF, for example, with the stack, and things get a lot more complex, right? And if we take a look at, we'll take a look a little bit later at the reasons why. But here are the things that cloud architects usually think about, right? There's 5 different domains that and things you got to keep in mind when you put together your AutoScaling architecture. And the number 1 and number 5 are most important, right? Overall, right, you obviously have to have multiple availability zones. That's a given. What you don't want is the data center at Amazon to go down and take down all of your infrastructure. You obviously are looking for scaling parameters. You're looking for it to be self-healing, right? These are all self-explanatory things. But you also have to design for failure, right? And that's where security is not always designed for failure, right? Security is a lot of times very much monolithic and fixed. So as a result, cloud architects end up rejecting them. And most complex is loose coupling, right? And that's a concept of separating functionality so much that there is as little interaction as possible, and components are as independent as possible, right? This is where things get fairly complex, right? When you're dealing with a vendor, for example, and they sell you a WAF, that's where you run into trouble, because that WAF was never designed for autoscaling. So one of the things you have to make sure you do is you have to make sure you choose components in your security stack that can be autoscaled. And one of the key principles for that is loose coupling, right? So what you're looking for are infrastructure that can be deployed with APIs. You're looking for components that are essentially designed in a black box, right? Obviously, components have to talk to each other, but they should talk to each other as little as possible, right? That interaction should be as abstracted as humanly possible. If you have software that is very, very tightly coupled, right, and requires full installation, right, for it to work, then at that point you can only autoscale kind of very much atomic instances of those security tools, right? And this applies to WAFs. This applies to pretty much any proxy device you want to put in front of your web application stacks. It's a fairly pervasive problem, and it requires us to think differently if we're going to autoscale security infrastructure, right? So, so one of the most important things to use as an underlying assumption is that if you're going to autoscale your security infrastructure, it has to be designed for failure. It has to be loosely coupled, and if it's not, that might be a reason why it needs to be built into the application itself. And you might have to sit down with your software development team and say, look, my security components don't autoscale natively. They're not necessarily loosely coupled. Can we rethink the way we deploy them right now? And can we restructure the way that they get rolled out? So let's use an example. And again, we're going to stay with web app firewalls. These architecture principles apply to pretty much any infrastructure you want to deploy. So think about any security components that you need to deploy alongside of your applications. These principles are pervasive, and they apply pretty much anywhere. But let's say we just try to deploy a typical WAF with Elastic Load Balancer. You could do something like this, right? You could have a sandwich, right? Have an Elastic Load Balancer instance at the top that's going to load balance between WAF instances. At the bottom, you're going to have all of your web tiers and all of your database tiers, right? Theoretically, this should work, right? Because Elastic Load Balancer will let you scale these WAF instances. And if you look at it casually, it might seem like this gets the job done. There's a couple of problems with this, right? First of all, WAFs usually have extremely slow boot time, right? So when a WAF comes up out of the box, it takes time for it to really get to the point where it can be in production, right? Those of you that have used web app firewalls before, you know that they have to go through a learning cycle. They have to learn the application and figure out all the application paths and make sure that the positive security model can actually have an impact. And it's not a 5-minute process, right? Usually learning cycles for WAFs take a very long time. It takes several weeks, and depending on how busy your application is, it could take quite some time for the WAF to learn the environment and really go fully into production. So a lot of times WAFs become those components that are useful but not really in a good fit for autoscale environments, right? They're also tightly coupled, right? And when you think about how WAFs are deployed, usually a WAF is kind of a monolithic device, right? It's usually an appliance. Even if you virtualize it, that WAF is essentially designed to be a single component, and if you need more capacity, you scale up. You buy a bigger WAF. Or you start to put them in clusters. That tightly coupled design is a very bad fit for Amazon-style autoscaling. So a lot of the times what we see is that customers will try to deploy their security stack alongside of their web applications and then quickly realize, this actually breaks a lot of my scaling. I'm just going to pull it out, and I'm not going to do this anymore, right? So There are different ways to approach this problem. So if we apply some of the things that we talked about in terms of loose coupling and designing for failure, there's a couple of ways you can restructure the way your security components interact with each other that will let it auto-scale much better, right? So we actually played through this exercise at Alert Logic, and we took our application and pulled it apart and said, look, we need to make our WAF stack as stateless as possible, right? And that means that every component should be a black box. Ideally, if the management plane goes down, there's no reason why the processing plane, right, the actual proxy, the blocks web traffic should go down as well, right? If you have components that trigger downstream outages, obviously that's an example of very tight coupling, and that's not a good thing, right? We want to decouple interactions between management and control planes, and I'll show you exactly how we did that. You really should make the communication between these components as asynchronous as possible, right? Because, for example, if your WAF proxy, right, has to go talk to some centralized console every time it needs to do something, obviously there's going to come a time where it's not reachable and it's no longer in production anymore, and things come crashing down. And what happens in auto-scaled environments, right? Let's imagine you have 15 WAF units that have been auto-scaled, and 3 of them go out of production because they can't reach the master controller that they need to talk to. Usually they'll trigger an auto-scaling event, right? Your elastic load balancer will realize there's not enough capacity here, I got to deploy more infrastructure. It'll bring up more WAFs, and if that controller is not reachable, they're not going to be able to come up, they're not going to be able to spin up properly. Even after the cooldown period, they're still not going to work properly, and it's going to continue to spin more and more WAF instances. And that's actually where auto-scaled environments, that's the downside of them, right? This isn't very sophisticated logics, right? Logic. So if your environment starts to auto-scale and the instances that are being brought up don't come up properly, all of a sudden it just keeps spinning more and more of them. At some point you're going to hit a max limit and you're going to experience an outage. And at that point, again, that's what the DevOps team or the operations team says, you know, we were just fine before we started deploying the security stuff. We don't need it, pull it out. Availability for us is much more important than making sure that we have our security layers implemented as well. So if you were to pull them apart and if you were to make them as decoupled as possible, here are the couple of steps that you can go through. And again, you can apply these lessons to pretty much any security application that you're deploying. So anything that runs in front of your application stack could theoretically work this way, right? So again, we're still using elastic load balancer, but we've separated the control plane and management plane, right? So the controller that tells the WAF appliances which appliance needs to be in production. What did the learners say, right? When you learned what that application environment looked like, you shouldn't have to do that every time you spin up a new worker instance, right? So the controller should really be separate from all the worker roles, right? Those worker roles are the ones that are going to auto-scale linearly. That controller only serves a very limited function. It just needs to be there to collect log data, and to provide configurations directives to all the workers, right? But really, these are separate pieces of infrastructure. Yes, there's a question. Yes. Yeah, we're talking about how a WAF should be structured in order for it to work in Amazon environments. It would be in Amazon, right? So it would essentially sit, it would still look like this, right? It would still sit in front of your web servers, right? It would sit in front of the elastic load balancer that scales the web tier, right? But in front of it, there would be a WAF layer, and that layer itself would be auto-scaled as well using elastic load balancer, right? No, usually, I mean, these are third-party services, right? So there's a whole lot of WAFs in the market out there, and you know, we have one. There's a lot of vendors out there that sell others, right? Very small right now. The problem with WAFs they've been so tightly coupled for many years that there's a whole lot of Amazon applications out there. There are very few of them that have WAFs deployed in front of them. That's correct, and that's primarily because of the way the WAFs were always built. So There is an approach that you have to take with not just WAFs, but really all security infrastructure you're going to deploy in front of your your web instances in order for them to autoscale. It is possible. We've done it with a whole lot of our customers, but it's not trivial. It requires a lot of architecture change. And again, these are things that are really native to any autoscale environment, right? So just because we've applied it to a WAF in this case, loose coupling and designing for failures really should be a fundamental premise. And it's one of the things that we find most security people don't think about, right? Usually cloud architects, that's all they think about. Security people, that's usually last thing on their list, right? So we're going to separate the control planes and the processing planes. If you have a complex application that needs to have a control plane, you never want to have that be tightly coupled with your processing plane. We're actually going to use two separate elastic load balancer instances and have one group for the master, one group for all the auto-scaled components, right? And that master is actually going to stay in a single instance formation, right? That auto-scaling group, even though it's called auto-scaling group, it really doesn't auto-scale that. There's only one instance in that box because we only need one of those, right? That's the controller, and even if that controller dies, the application stack should still continue to run, right? So if you look at the master auto-scaling group, for example, it's got a minimum size of 1 and it's got a maximum size of 1. We never want more than one controller in there. Even if it needs to restart and even if it takes about 20 minutes for it to come up, that's not a problem. The WAF instances should still be able to run even without the controller being there, right? Now, the group that actually scales the worker instances, right? Those are the ones that actually process the traffic and filter out attacks. Those have to auto-scale pretty dramatically. The minimum for that for us is 2 instances. You might want to go with something higher than that because your minimum footprint might be bigger than that. But in terms of max, we haven't found a max yet. We've actually pushed this to about 10 gigabits with our customers, and so far it's worked out extremely well. We just keep on bringing up more and more instances, and more of them work. They come up and they spin up, and about 5 minutes later, that WAF instance is fully warmed up and fully in production, right? Reducing and abstracting interactions. There's some interesting things you can do here if you leverage native Amazon infrastructure, right? So when a WAF instance comes up and it's been auto-scaled, the number one thing it needs is to get a configuration from something. And you want to get that instance bootstrapped as fast as possible, right? So you're looking for less than 5 minutes of bootstrap time. So that instance is going to come up, it's going to get its configuration directive from S3. S3 is actually a service that Amazon maintains, right? So S3 storage is really good for distributing configuration files, right? So we've decoupled this interaction pretty dramatically, right? The master never talks to the workers directly. They speak through Amazon infrastructure. So for configurations, essentially the master writes the configuration to S3. Worker instances come up, read it from S3. So even if the master is not there, this stack will continue to run. You can still spin up new instances, right? So again, that master doesn't really need to be there, right? It's there to make sure that it can catch logs. But other than that, as long as the configuration file is still fresh and it's still in S3, and S3 is a very reliable service, you should be able to auto-scale your workers. You should be able to handle more and more traffic, right? So using Amazon native storage mechanisms does free you up quite a bit. Now S3 is really useful for things like configuration data, but if you store log data and you don't want that log data to be wiped out, persistent storage for that is much more useful, right? So those worker instances for us, for example, they log all of their activity to the master. That master writes it to EBS, right? So elastic block storage is persistent storage that we keep in place in order for it, in order for that storage to not go away, right? So even if the master instance has to terminate and come back up again and reattach to that EBS volume, that volume is still there. All the log data hasn't gone away, and we can pick up exactly where we left off, right? So again, using native Amazon services to abstract and to decouple interactions as much as possible, right? And that's really about it, right? It's actually not that complicated. So at this point, when you look at the web traffic flow, this is exactly what it looks like, and that's the question you asked, right? What does this look like in Amazon, right? You're going to have elastic load balancer that's going to load balance all of your WAF instances. You're going to have a series of WAF instances that are going to be controlled by the first elastic load balancer layer. There'll be another elastic load balancer layer behind it that scales web infrastructure. And those two tiers can now scale independently. Obviously, you don't need one-to-one relationship between the number of servers, between number of WAFs, right? For usually, at least with the customers that I've seen in deployment, usually we have about a WAF for each 5 or 6 servers, so there's not a one-to-one relationship. Those really should scale in different parameters, and you can configure them to be separate, right? So far so good. We've essentially done it, and we've been able to take security infrastructure and make it as scalable as cloud infrastructure and make it high scale. The problem is that it's fairly complicated, right? By the time you're done, you have a fairly complex setup with kind of several layers of auto-scaling and load balancers, and a whole lot of infrastructure you got to spin up, right? You got to spin up multiple ELB groups. You have to configure a lot of files. You have to spin up S3 and EBS volumes. So it's kind of a beast to configure. And again, if you come to an application team and say, look, I have a way to auto-scale WAF instances, for example, it just requires this long list of things to go configure, they're going to look at you like you're nuts and nobody's ever going to deploy this. So even though this infrastructure is fairly complex, you can't automate this fully, right? So we actually have security teams, for example, that look at this type of deployment and say, we're going to automate this entire stack and let our production teams essentially spin that up without us, right? And the easiest way to do that is to use CloudFormation scripts, right? So CloudFormation is a very powerful templating language that Amazon uses. There's a lot of them out there. You can actually do templating with and automated deployments with a lot of tools out there. But CloudFormation makes it especially easy. And here we essentially have a blend of things that the security team essentially bakes into the configuration. Those things should never change. Plus things that should be defined by either customers or by the operations teams, right? So if you give them these CloudFormation templates, you may not know which availability zone they want to drop this into. You don't know their IP address ranges. This could be a very simple web form, right? So they go through a wizard, they go through a series of CloudFormation-driven steps, and at the end of the day, they have a stack that's fully spun up. You can do the same thing with at the command line as well, right? So CloudFormation is not just the UI for configuring infrastructure. You can do all of this at the command line as well. So if your production team essentially says, you know, my data centers in the future in Amazon are going to be instantiated 100% automatically. Actually, we're launching a new data center for Alert Logic in UK over the last week or so, and that data center is hands off, right? That data center, we plug it in, we give a couple of commands to our auto-scaling routines, and that data center gets spun up on Amazon 100% automatically without manual configuration any step of the way. This is a scenario where CloudFormation templates developed by the security team can actually be plugged into an entire data center being deployed, right? So if the production team says we need a different environment in Australia, they can easily take this and spin this up and use this without having to wake somebody up in the middle of the night, have a project plan and a maintenance window. Security infrastructure really needs to be as automated as application infrastructure. So I would watch closely what your production teams do and kind of model your level of automation behind them, right? So either through command line or the UI components of CloudFormation, you essentially create a stack and you can really give them a full-blown security installation that they can plug into their environments, and it should be fairly simple by the time you're done. So we actually ran this test at the Amazon conference last year. This design was actually was developed by us alongside of Amazon. Amazon helped us kind of think through a lot of the moving parts in terms of how we're going to auto-scale these WAF deployments. But we actually had an environment we built at the Amazon reInvent conference last year. We had a couple of servers that we started to pound with more and more traffic. So by the time we were done, we had 34 WAF instances, and they were processing something like 10 gigabits of traffic, right? So these are exactly the same instances, right? They were cut essentially from the same instance size. I don't remember which one exactly we used, but I think it was an M1 large. That's one of the instances that has multiple cores in it. So we essentially were able to, and this happened during the actual session that we did at this conference. We actually were sending more and more traffic and scaled it up higher and higher. So this was a lot of fun to work on. So I kind of promised at the beginning that I'm going to address the platform as a service. Platform as a service is more complicated, right? With infrastructure, you at least have visibility and control over all of the infrastructure that you're deploying, and it's really up to you as a security admin or your operations team to control all of that infrastructure. Platforms are more complicated than that. Even though the infrastructure is there, that infrastructure is really orchestrated by Microsoft is a big proponent of this and so on. So we have been able to do this with Microsoft, but it's more complicated than that, and usually requires a lot more manual hand-holding before you go off and do this. But it is possible, and really the principles are the same. If your security infrastructure is not loosely coupled and is not designed for failure, it's not going to work in PaaS environments either. So I think we have a couple of minutes for questions. Yeah. This could be either a good thing or a bad thing. Well, thank you very much. I appreciate it.